our last unit, and we're going to compare the three functions that we have talked about all semester long. Remember, the first function we talked about was linear, and that is y equals mx plus b. The second function we talked about was quadratic, and that is y equals ax squared plus bx plus c. And the last function we talked about was exponential, and that function is a times b raised to the x. Remember, linear functions have a straight line. Quadratic functions are a parabola, which is a U-shaped curve. And exponential functions have an asymptote they get really close to, and then they curve up. Okay. So from review, if you have an equation, how can you determine if it's linear, quadratic, or exponential? Well, linear functions are just going to have a plain old x. Okay. There's no exponent. And we have two terms. Quadratic, remember, has an x squared. So I have a leading exponent of 2. And I have up to 3 terms. An exponential function, remember, is some sort of base raised to the exponent, x. Okay? And our exponent is my variable x. So take a second. With that memory being jogged, can you identify which ones are linear, exponential, or quadratic? I hope you paused the video so you can recognize which one of these are linear and which one of these are quadratic, and which one of these have an exponent, so they're exponential. Now let's talk about if we look at them on a graph. Okay. So if you have a graph, how can you determine whether it's a graph of a linear, quadratic, or exponential? Well, remember, a linear function has a straight line. A quadratic is a U-shaped curve. Which is called a parabola. And our exponential function is a curve, more L-shaped, and I should have a distinct picture of the asymptote. So go ahead and pause the video again and see your knowledge about identifying which graphs are linear, quadratic, or exponential. I hope you really did pause the video and recognize that these functions are linear, these functions are quadratic, and the remaining functions are exponential. So check your work there and then flip the page over for the last little bit of notes. So we've talked about an equation, we've talked about a graph. Now let's talk about a table. When I'm given a table of values, I know something is linear if I am adding, wrong color, if I am adding or subtracting by a constant rate. I know I have something as quadratic if I notice that I have a vertex, which we call a mirror point, or we have something called the second difference. We know we have exponential if we are multiplying by a constant, an increasing rate. Okay, we have that common ratio R, where in linear we have that common difference D. Okay? And when I'm saying adding and subtracting by a constant rate, I'm talking about the y values if x increases. And in exponential, I'm also talking about multiplying by an increasing rate, okay, multiplying by R for my y values. Okay. So looking at this first table here, okay, we notice that our x values are going up by ones, which is good. So let's look at what my y values are doing. I am subtracting 4 each time. 14 to 10, 10 to 6, 6 to 2. That represents a linear function. I'm adding and subtracting by a constant amount each time. Let's look at the second example here. I'm going up by ones, which is good. So now I can look at my y values. To get from 2 to 4, I'm multiplying by 2. I can't be adding 2 because 4 plus 2 is 6, and I need an 8. So 4 times 2 gets me 8. So this represents an exponential function. Our next example here is also going up by ones for x's, which is good. So I can look at my y values. How am I changing? I'm adding 3. Put in your calculator negative 16 plus 3, we should get negative 13. Plus 3 should be negative 10. So this is also an example of linear. Now let's look at our fourth example. My x values are increasing by ones, that's good. But here I'm subtracting 10. Here I'm subtracting 8. Here I'm subtracting 6. So this is not linear. That is not constant. That is not okay. Here I'm multiplying by 1/3. Here I'm multiplying by 0. That is also not constant. It cannot be exponential. So just by process of elimination, we can say that this is quadratic. It's also quadratic for what we talked about as the second difference. I already took one difference, 30 minus 20, and got 10. My second difference is going to be 2. I subtracted 2. 10 minus 2 gets me 8. Subtract 2. That is a constant second difference. That emphasizes that this is quadratic. Before doing any math on our fifth example here, how do I know this is quadratic? Take a look at the table. Do you notice that we have a vertex? I get the same y values on either side. This represents a mirror point, which is my vertex. So this has to be quadratic. Can we find a mirror point in our next example? Yes. That mirror point is at 2, 4. I get a negative 3 on each side, and I bet if our table continued, we would find more. So this is also quadratic. Can we identify our last two examples here? Are they going to be linear, quadratic, or exponential? This first example that we have left, I'm adding 5 each time. That constant addition is linear. In this next example here, I don't like fractions. I don't like to see them as much. I'm going to focus on my whole numbers. Am I adding the same thing each time? No, that's not linear. Am I multiplying by 2 each time? That answer is yes. That constant multiplication, or that constant increase, an increasing rate, represents an exponential function. We will focus on the second half of this page later. I just want you to be able to identify linear, quadratic, and exponential by either an equation, a graph, or a table. We're at the conclusion of our notes, but I would like you to finish off by completing this page. With those notes, can you identify those 10 questions as either linear, quadratic, or exponential?